Hello everyone. Today in this next lecture we are going to look at the calculation of gauge pressures and absolute pressures. And so we have two questions, and question one is as follows. Question one: given that barometric pressure reading is 740 millimeters of mercury, specific gravity of mercury is equal to 13.6, and the intensity of pressure that was measured as gauge pressure is 40 kilopascals. Then the question is saying express the intensity of pressure in SI units as for gauge pressure and absolute pressure. So we have been given the question to express the intensity of pressure given as gauge pressure and absolute pressure in SI units. So first of all, let us solve. Solution. Our pressure, the pressure P is 40 kilopascals. So this pressure is in kilopascals, and we can convert it to pascals as 40 times 10 to the power 3 pascals. So gauge pressure P, gauge pressure P gauge is therefore equal to 40 times 10 power 3 pascals. It can also be PG, that is gauge pressure, can also equal to 40 times 10 power 3 Newton per square meter. Now in bars, we know that one bar is equal to 1 times 10 power 5 Newton per square meter. So it means if this PG, the pressure gauge, if needed in bars, it is equal to 40 times 10 power 3 pascals, okay, divided by 1 times 10 power 5. So this is going to be this is 40,000 divided by 100,000. So cancelling these zeros, we will remain with 4 out of 10 bars. So it means the pressure P gauge, or our gauge pressure which is required, is 0.4 bars. So we have given it in SI units of pascals, Newton per square meter, and also in bars. So if that is the gauge pressure, which is the intensity of pressure given or which was measured as gauge pressure being expressed in those different units, let us now look at absolute pressure. Absolute pressure. So we know that P absolute is equal to P atmospheric plus P gauge. From what we have already discussed, we have P gauge, so we need to get P atmosphere. So P atmospheric is 740 millimeters of mercury. So for us to have absolute pressure, for example in pascals, we need to convert this pressure from millimeters of mercury to pascals. So from the hydrostatic law, we know pressure is equal to H rho G. H, we have it, H is 740 millimeters, which is the same as 0.74 liters of mercury. Rho is density of mercury, and it is from specific gravity of mercury times the density of water. So this is 13.6 times 10 power 3, and this is in kilogram per cubic meter. Then G is known as 9.81 meters per second square. So substituting those values in the hydrostatic law, then it means P is equal to H, which is 0.74 times 13.6 times 10 power 3 times 9.81. So using the calculator, it is 0.74 times 13.6 times 10 power 3 times 9.81. So this pressure P, this is P atmos, is equal to 7.84, and this is in pascals. So we need to convert this to bars, so that we convert it to bars, then later on we can find now the absolute pressure in the bars, to find the absolute pressure in pascals. So it means if we are asked P absolute, which is the sum of P atmosphere plus P gauge, then this will equal to 98727.84 plus the figure we got above in pascals is 40 times 10 power 3, 40 is 40 times 10 power 3. So if I add 40 exponent 3, the absolute pressure, therefore the absolute pressure P absolute will equal to 138 7 to 7.84, and this is in pascals. This is in pascals. So this can be 138.72, maybe 8 kilo pascals. So if we want it in bars, then we can just convert this figure into bars. So P absolute is equal to 138.728 times 10 power 3 over 1 times 10 power 5. The whole figure is in bars. So what will this give us? Divide by 1 exponent 5. This will automatically give us 1.387 bars. So here we have solved the problem by giving gauge pressure in SI units, then also giving absolute pressure in the SI units as it was required us. So let us look at the next example. Question 2. Calculate the pressure at a point 5 meters below the free surface of water. Calculate the pressure at a point 5 meters below the free water surface in a liquid that has it should be below the free water surface, in a liquid that has a variable density given by the relation rho equal to brackets 350 plus AY, the whole thing in kilogram per cubic meter. So where A is equal to 8 kilogram per cubic meter, it is power 4, 8 kilogram per m to power 4, and y is the distance in meters measured from the free surface. So calculate the pressure at a point 5 meters below the free water surface in a liquid that has a variable density given the relation rho equal to 350 plus AY, where A is equal to 8 kg per meter power 4, and Y is the distance in meters measured from the free surface. So if we are to solve this solution, we shall record the hydrostatic law, the hydrostatics law given by that P, we know that the rate of change of pressure, or the rate of increase of pressure in a vertical direction, that is dP dy, is equal to the specific weight of the fluid at that point. So having stated that relation, we know that dP is therefore equal to W dy. But small w, or the specific weight, is the same as density, which is rho, times the acceleration due to gravity. So introducing the relationship between density and W, then dP is equal to rho g times dy. But we know rho is given in the relation as 350 plus AY. So it means dP is equal to 350 plus AY, we close brackets, G, then dy. So from here, introduce integral signs. So meaning integrating dP from 0 to P is equal to integrating 350 plus AY G dy from 0 to Y. What will it give us? It will give us P, which is equal to it is giving us P, which is equal to, if we are integrating, we increase here the power by 1 and divide by the new power. So this will be 350 y plus a y squared over 2 into g from 0 to y. So P is therefore equal to 350 plus AY over 2 into GY. So that is the relation that has been derived, and so our task now is to put in the figures. So our question says calculate the pressure at a point 5 meters below the free surface, the free water surface, in a liquid that has a variable density. So it means we are going to substitute in a figure of y equal to 5, because y, we know as from the derivation, y is the distance vertical distance, actually vertical distance below the free surface. So therefore put y equal to 5. So P will equal to 350 plus A times 5 divided by 2 into G, which is 9.81 times 5, because y is 5. A is also given. A is also given as 8. So P therefore will equal to 350 plus 8 times 5 out of 2 times 9.81 times 5. So using a calculator, we can find that P is therefore equal to 350 plus 8 over 2 times 5 times 9.81 times 5. So P will equal to 148.5, and this is in pascals, or it can be given as 1.815 kilopascals.